The only thing that has changed since we did grade 10 exponential functions is that p-value over there. So that means that the graph is going to shift to the right for ones that are negative and to the left for ones that are positive. Remember, that's a counterintuitive shift for most of us. Just a reminder that the a value is going to be positive, then it's going to be above here, and the a value will be negative when the graph is at the bottom. For your b value, it has to be bigger than 1 or a fraction. If it's bigger than 1, it goes that way, and if it's a fraction, it is a decreasing function. When we're drawing an exponential graph, we need to plot the asymptote, the intercepts with the axes, and we need to also plot a negative and positive x value so that we can get the shape of the graph. So it is the same thing for the hyperbola. Your asymptote, it's going to be horizontal, will be your -4 there, or the q value on the formula for the graph. The y-intercept and x-intercept will work exactly the same. We're letting x equals 0 for the y-intercept, and we're letting y equals 0 for the x-intercept, and solving. Remember to put points down with the value so that you know what you're plotting. The extra points then, I've subbed in -1 and 1 for x and gotten out -3.5, which we must remember, if it's a fraction, to write as a mixed number, because that's much easier to plot than 7/2. For the other extra point, I got out 1 and -2, plotting all 4 of those and labeling the points as I go. And I must remember to join them in a curve without touching the asymptote. When we're finding the equation of an exponential graph, we've got lots of variables. So they tend to give you more information or leave out the a value or give you a partial equation that's already got the b value in it. Remember, you're probably going to be given the asymptote, which you sub straight into the q value, or you could be given intercepts with the axes, treat those as points, or you could be given an a value already or a b value already inside the equation. You're subbing in and you're normally solving for b. For the domain and range, remember that these functions go infinitely left and right, which makes the domain x an element of real numbers. The range will go from the asymptote up or from the asymptote down to -infinity. Exponential functions either increase for all values of x or decrease for all values of x. When we transform these graphs, we are either asked to do the shifting ourselves, or we're given a shift and we're asked for the formula. In functional notation, we're going to add things to the q value to shift it up, or subtract things from the q value to shift it down. It's then going to show us that to the entire graph we are subtracting a number. So we're subtracting up there, and that is the new formula. When we're shifting left or right, we're going to change the p-value. Remember that when we shift left, counterintuitively, the p-value now increases and will decrease if we shift to the right. That shift in the functional notation is going to happen inside the brackets because you're changing the x value, not the y value. The new equation would look like that. For reflections, we are dealing with reflecting in the x-axis where y becomes negative, so you make the whole graph, this is the y, negative, and you multiply the negative into the entire equation. That is the equation of the new graph. When we reflect in the y-axis, the x's become negative. So instead of f of x, we now have f of -x. Therefore, every time we see an x in the original equation, we now put in a -x. Changing that so that your x is a positive value means you end up changing the b value to a fraction, which means it is that graph that is now decreasing but still above the x-axis.